Hello everyone, welcome back to a new video of Structural Simplified. Today we're going to talk about supports and reaction forces. So a beam needs something to rest on, but what kind of support is it using? In this video we will look at different types of supports, how they resist forces and how to calculate the reactions they create. So this is a beam. From now on, I will draw them just as a line like this, but obviously they have a height. This is a simply supported beam with a so-called pinned support. We have a roller support. And we also have a so-called fixed support. And I will go through each one of these. So a pinned support can resist forces in the horizontal direction and in the vertical direction. So this support will provide resistance we will have a reaction force in this direction, in the vertical direction, and also in the horizontal direction. Let's call it H. While a roller support, like we can hear the name, it rolls, so it doesn't resist forces in the horizontal direction. So it only resists forces in the vertical direction. While a fixed support, like in cantilever beams, for example, if you have a shelf that is fastened in the wall, but it doesn't have any support at the end, so it doesn't have any support here, in this point. A fixed support resists not only vertical forces and not only horizontal forces, but it also resists rotation in this particular point. So that means no movement or no rotation at all in this particular support point. But in reality, no support is perfect, but these idealizations helps us analyze structures efficiently. So each support introduces reaction forces, and these are what we solve for equilibrium equations. So, like I said, here we have two forces, here we have one force, and here we have three reaction forces. And obviously you can combine, for example, a fixed support with, for example, a roller support, and then have a cantilever. You can, but then this is no longer statically determined. It is called statically indeterminate. And this means that we can't use these three equilibrium equations that I told you about in the previous video. You have to use other deformation equations for this. Or you can use other methods such as finite element method or the element-based displacement method and so on. So let's look at a very simple example regarding how to solve for these reaction forces. If we have the most simple case, a simply supported beam like this, subjected to a force F and a horizontal force N. And let's say that F is equal to 10 kilonewtons and N is equal to 5 kilonewtons. And the length of the beam is 10 meters in total, but 5 meters on each side like this. So the force is acting exactly in the middle of the beam. So, like I taught you in the last video, the horizontal equilibrium. First of all, we have to draw a free body diagram of the beam, which is basically that we translate. Here we have 10 kilonewtons. Here we have 5 kilonewtons. And then we have this reaction force, we translate it to, let's call it RB, because let's call this point B and let's call this point A. Then we have the reaction force in point A here. And finally, we obviously have the horizontal force in point A as well. So we can easily see that we only have two horizontal forces, which is HA and the normal force N, like this. And I have defined the positive direction as the force pointing towards the right. So we have that the horizontal force A plus 5 kilonewtons is equal to 0. And that gives us that HA is equal to minus 5 kilonewtons. And this very well corresponds to what I mentioned in the previous video, that each action has an equal and opposite reaction, and we can see it in action here. Horizontal equilibrium, the reaction force in A plus the reaction force in B is equal to 10 kilonewtons. And then lastly we have the moment equilibrium. And something that is very important regarding moment equilibrium is that when we have a free edge, for example here or here, then the bending moment is equal to 0 because we have a free edge. But we can't, for example, this equation is not valid if we, for example, choose this point or this point, because the moment around there is not equal to 0. So please keep that in mind. So we can choose if we want to do this moment equation around point A or point B. I will choose point A. And I will choose counterclockwise as my positive direction. So from point A we go towards this force F. And if we go with the right hand rule, then we know that it's clockwise. So around the point A, the force F is acting clockwise, so that's a negative sign. Minus F, which is minus 10 kilonewtons. And the lever arm from this point to this point is 5 meters. Then we have the next reaction force, which is RB. From point A to point B, we have 10 meters. And as we can see, the reaction force in point B is acting counterclockwise if we look in relation to point A. So that's a positive sign. We have RB, and the lever arm is 10 meters from this point to this point. So 10 meters equal to 0. From that, by simplifying, we have that RB times 10 meters is equal to 50 kilonewton meters. So if we divide by 10 meters, we know that RB is equal to 5 kilonewtons. And then by this equation, we know that RA plus RB is equal to 10 kilonewtons, and hence RA is equal to 5 kilonewton. So RA is equal to RB. And that makes total sense, right? Because it's a symmetrical beam in the vertical direction. So it doesn't make sense that RA and RB would not be the same value. Obviously, this is the most simple case. So in many cases, it won't be symmetric like this. So you may have the load here. So in that case, you can't just assume, they're the same. You have to actually make calculations. But if in the cases where you have symmetry, then you can just go ahead and assume that RA and RB are the same, because they will be. Now that we have figured out the reactions, we're ready to move forward. And in order to figure out what's going on inside the structure, we need to isolate it and find out what the internal forces are as well, in order to properly design the beam. That will be in a future video. Thank you very much for watching another video with Structural Simplified, and make sure to like, subscribe and comment if you have any suggestions, and I'll see you in a future video. Thank you very much.